to be able to do the truth tables for the conditional and biconditional, we're going to start with the conditional and we're going to look at a very specific conditional phrase. So the one we're going to consider is, I'm going to make the statement to you, if you get an A, then I buy you a car. Okay? So P is the statement, you get an A. Q is the statement, I get you a car. So again, this is the antecedent, this is the consequent. So again, I still have 4 combinations for P and Q, the same 4 that it runs through. What I want to ask is, based on those starting values, when is the conditional statement true? And the thing you have to think of is, I don't want to break my promise to you. That's what an if-then is. If this thing occurs, then this thing has to happen, okay? So if you get an A, I better buy you a car to not be lying to you. So we're going to break it down case by case, starting with case 1. Here, both P and Q are true. So in this case, both you get an A and I bought you a car are true. Okay. So you got an A, so then I bought you a car. I upheld my end of the deal. So within this, I kept my promise. So this conditional statement, if P happens, then Q, is upheld, so it is true. You got an A, so I bought you a car. Looking at case 2, P is true, but Q is false. So you got an A, that's true, but I did not get you a car. So I broke my promise in this situation. So the conditional is not true for this scenario. Moving on to case 3, P is false, but Q is true. Okay. You did not get an A is the meaning behind the first part. But I still bought you a car. So if you think about the condition, you failed to meet the condition. So what happens as a consequence does not matter at all. You did not get an A, so I can do whatever I want in return. This works good for you. You still get the consequence, even though you didn't meet it, but I didn't break my promise here. So I didn't break my promise because you didn't uphold the condition needed. So what I do doesn't matter. So overall, this statement is true. And likewise, when I get to scenario 4, them both being false, you didn't get an A, I didn't get you a car, I didn't break my promise because you did not keep up with what you needed to be doing. So I still didn't break my promise. So the conditional is true. So going back up to our chart, this one is true. The only problematic scenario is case 2. Starting true and going to true, good. The true to false is my problem. You met the condition, but I didn't follow through. This situation of false to true is good, and false to false is also good. Okay, so this is the only bad scenario. Okay, so to just summarize that down here, the conditional statement P to Q is only false in the case where you start true and do not follow through with the consequence. Okay. So let's try an example combining these together. We're going to construct a truth table for this conditional statement. And again, it's a conditional because the main operation is that arrow, conditional. Before I can do this, I've got to again find that negation. So my very first step is going to be find the negation of P. As soon as I have this, I have these truth values. We then can go ahead and find the overall statement. Okay. So running through my scenarios, still the same for starting values. Okay. To find not P, I'm going to go ahead and negate these values. So we flip them to false, false, true, true. Okay. To do this conditional, I'm going to start by putting not P's values in the corner. So that's false, false, true, true. The operation here is the conditional. And then I want to copy Q's values, which alternate back and forth, true, false, true, false. So the only scenario I'm having to consider is if you start true and it leads to false. So in these first two, you didn't uphold at your end of the bargain. Honestly, this ending piece does not matter at all. This statement will be true for both of these. When you start out true, you have to make sure you don't break the consequence and you don't hear. So this one is good. This fourth and final case, you met the criteria, but I did not follow through with it. So this end statement is false. Okay. So that is our conditional. Again, the only situation you have to be aware of is when it starts true and leads to false. All right, now that we've got the conditional, let's look at the biconditional. Okay. So if I have the biconditional, it means you have two arrows going on. You have the forward arrow, so if P then Q, and you have the other arrow, the backwards direction. So in this case, Q becomes your antecedent and P becomes the consequent. So if I want to consider the truth table for this, I'm really going to look at these two different ones first. Okay. So statements P and Q run through the same possible combinations. We've got the forward arrow, and then we've got the backward arrow, which starts out with Q and goes to P. And this will tell me what happens with the double-sided arrow, because really this is just the forward arrow and, which is this operation, is the backward arrow. Okay. So we're going to start out with the forward direction. So I'm basically putting the arrow in this way. Right? So I'll start by filling in P's values, true, true, false, false, the forward conditional, and then true, false, true, false. This is my one problematic scenario. You start true and land at false, but everything else is good. When I go to do the reverse arrow, all that's really doing is flipping the direction. So we're putting Q's values first, which is TF, TF. And we're doing that conditional statement. And P's values are TT, FF. So just copying those down after. So I have to look out for my problematic case. If I start true, it better end true, and it does. So this is good. Starts false, so really what happens at the end doesn't matter. It's overall true. Here it starts true, but ends false. That's the bad scenario. You kept your promise, or you kept your end of the deal. I did not keep my promise. And then false, whatever happens after false doesn't matter. So overall, this is true. So for the biconditional, we're figuring out, are both conditionals true? Can you put the arrow either way? Okay. So if I look at my first case, the forward arrow is good, the backward arrow is good. So the truth values here are T and T. We're asking, are the forward arrow and backward arrow true? And the answer is yes. So overall, the statement or the biconditional is true. Moving on to the second case, the forward arrow is no good, but the backward arrow is. So if we're trying to figure out if they're both good, the answer is no. So this is false. Third case, same thing. One arrow works, but the other reverse arrow does not. So no, both arrows aren't good. And in the final case, the forward arrow is good and the backward arrow is good. So overall, that biconditional is good. Okay. So to condense this to a better truth table with just the end statement, the values were true, 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 false, false, true, false, false. If you consider these first two, this arrow forward is good, the backward is good. This led us to a true biconditional. In the second scenario, the forward arrow is no good. So overall, they're not both good. The biconditional is false. For the third situation, putting the arrow this way is no problem, but the reverse is no good. So the biconditional is false. For this last scenario, the forward arrow is good, so is the backwards. So overall, the biconditional is true. Okay. So you can see a really nice pattern. when they match, the biconditional is true. If the truth values differ, you have a false biconditional. So what we have left to do now that we know the main truth tables for each of these core operations is we're going to make it complicated and mix everything together. And then I'm also going to go over some definitions just for terminology with this. So we're going to make that distinction once I have tons of operations, which is a compound statement, which is a conditional statement. And so we're going to construct a truth table for the following 3 different things. So our first statement is quite a doozy, but at least thankfully it is only going to be 2 statements, P and Q. Thinking of your order of operations, you've got to do this first because it's in parentheses. So ultimately here, this is our main operation. This is the very last thing I need to do. So because of this, this is a compound statement, not a conditional. It has a conditional in here, but that is not the main or the last operation that I need to do. So running through my scenarios first, just to get this table prepped, we'll then figure out all the different headers that we need. So you can go ahead and say, okay, well, I need to do what's in parentheses first, so I need to find not Q. As soon as I have that, then I can do these things. Before I can do this, I need to then find not P. But really, the negations are the simplest ones, and so if I need both of them, I like to just throw them in the front. Because these, I just really just get to copy down. So not P will be false, false, true, true. And then not Q is going to be false, true, false, false. Okay. Now I'm going to work in the parentheses. I've got Q's values. I've got not Q's values. I then can do my biconditional. So starting with Q's values, that would be these ones here. That's true, false, true, false. We're doing the biconditional, so our double-sided arrow. And then I need not Q's values, which are all right here. So I copy those down next, F, T, F, T. For the double-sided arrow, I'm looking to see if they match up. And if I look at any of these, they are differing values. So the biconditional is going to be false in every single one of these scenarios. And that makes sense if you think about what this phrase means. Q, if and only if, not Q. They're contradicting statements to each other. So there's no way this can happen. Okay? Now I've got the values for this. I've got the values for not P. I'm now set up, I can do this AND operation. So we finally can do not P and Q if and only if, not Q. So starting with P's values, we'll copy those in the corner, or not P's values, FFTT. Our operation is end. And then I need to copy my values for Q if and only if not Q. And those were all F. So for end, I need them both to be true. But if I look at all of these scenarios, I do not see a T and T. So overall, we always end up with something that is false. Okay. So because of that, when I have a statement that's always false, in this case, because it's a compound statement, this is called a self-contradiction. And again, keyword being this is compound because the main operation is the end. So no matter what you start with, this phrase always results in something that is false. You are contradicting yourself. Okay. So that's our first example for a truth table. Let's try another one where again, our main operation is going to be this or. Because I've got to do this, that creates truth values for this statement, truth values for this statement. This is a compound statement. And thankfully, again, we only have two statements, P and Q. So run through all of those combos. Okay. So if I look at the negations that I'm going to have to apply, I only have to do it to Q. So I need a column with not Q. Then I have these values. I have P's values. So I can go ahead and figure out the truth values for the thing in parentheses. I've got these truth values. I've got these truth values. So now I'm set up to be able to do that final statement. Okay. So going through our different scenarios, to find not Q, I'm going to switch all of these values. So not Q will be false, true, false, true. To do my conditional, I've got to start by putting not Q's values in the front. So false, true, the conditional. And then I go ahead and copy P's values, which are true, true, false, false. So with my conditional statement, I'm looking for the problematic case, which appears right here. You start true and lead to false. Start true, lead to true, that's good. And when you start false, the ending doesn't matter. So these three are true, but this last one is false. Okay. For the third and final step, I'm going to start by putting this conditional phrase in the corner. Those truth values are true, 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 false. We're doing the OR operation. So then I need to put not Q's values, which are FT, FT. And with OR, I need at least there to be one T. Yes, 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 there is at least one true in every single scenario. So I end up saying something that is always true. So just like when it's always false, that's a self-contradiction. A compound statement that is always true is called a tautology. Okay. the last case we're going to consider is what if the main operation is conditional. And the only vocab we're going to be concerned with here is when you end up with something that is always true. Okay. So our third and final example is going to be this one here. So again, you got to do this first before I can do this. So my main operation here is this conditional. Okay. So this is a conditional statement. If it was a double-sided arrow, it's still a conditional statement. Okay. And thankfully, at least, I don't need to find any negations, but the very first thing I need to do is I need to find P or Q. Then once I have these values, I have P's values, we can go ahead and find this overall statement. And so again, I start by filling in my 4 combinations for P and Q. Okay. So starting with the OR, putting P's values are true, true, false, false. Our operation is OR, and Q's values are true, false, true, false. OR needs at least one to be true, so yes, yes, yes. And then unfortunately here, P or Q is not true, so this statement is false. For this end piece, I gotta start by putting P's values in. So P goes true, true, false, false. Our main operation is the conditional. And then I need to put the values of P or Q, which are true, 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 false. And so for conditional, when it starts false, it does not matter. So in the end, these two are true statements. When it starts true, it better lead to true, which it does. So this statement is always true. Okay. Now this one is a conditional statement because again, the last operation I'm doing is conditional. This is called an implication. So an implication is a conditional statement that is always true. Tautology is reserved for compound statements.